Hi, this is Mr. Nazarian. Our lesson objective today, I can divide 4-digit dividends by 2-digit divisors using multiples. It's 5th grade standard, numbers base 10B6. So first of all, because this is our first time really working with division, in division, let me just put this together real quick here. So if I had something like, let's just do 8 divided by 2 equals 4, right? If I take 8 and I divide it into 2 equal groups, there'll be 4 in each of those groups. When we look at a division equation like this, each of these parts of the equation have a different special name. So the number that we start with, that we're going to be dividing, is called the dividend. Okay, so the dividend is the number that really the biggest number, as long as we're dividing by whole numbers. It's the biggest number that we start with, and it's the number that we divide. When it goes like this, it's this first number here. If it looked like this, it would be the number that's inside of the box. Okay, so that's our dividend. Then we have the divisor, and the divisor is the number that we're dividing the dividend by. So we're taking the dividend and we're dividing it by the divisor. So that means how many groups we're breaking into, or how many are in each group to find out how many groups there are. This is the divisor, the number that we're dividing by. And then finally, and I don't have it written on here, but I will go ahead and type this up. This next one here, right here, is called the quotient. And let me find a green one here. Quotient. And the quotient is the answer to the division problem. Okay, so that's just a little bit of background, so we have this sharing the same vocabulary. So we are going to be dividing, and actually we're going to be dividing, we're going to start off with just dividing 3-digit dividends by 2-digit divisors, and we'll be working our way up. But we're going to start off with taking 864, so this is the dividend, and dividing it by 16, which is the, what is that called again? The number that you divide by is called the divisor. Okay, so 16 is a divisor here, and we're breaking this 864 into like this many groups, for example, or this many in each group. We want to find out how many groups. So as a reminder from yesterday, what we were working on is we built multiple towers, right? So that's how we're going to be approaching division this year. The standard algorithm of division is something that you will be working on in 6th grade. We're going to be using multiples and a couple other strategies to solve division problems this year. So this is how it works. So I'm going to take this divisor and I'm going to build, I can build a multiple tower of this, and as we go, it might be something that you just are kind of building multiple towers in your head, but it's a really good visual for now. So we have this multiple tower of 16. I'm going to show you 2 different ways to solve this problem. The first way is the longer way, and then we'll try it a way to see if it feels better and it's faster. But either way, you'll find that we get the same answer. Either way is just fine. So I'm taking 864 and divided by 16. I need to think about what are the multiples of 16. Well, if I build this multiple tower from the first up to the 10th multiple, then I can say, well, this is basically, and division is basically, it's the same kind of thing as repeated subtraction. So it's like if I had 864 cookies in a cookie jar, and every single day I came home and I like the Cookie Monster, man, I got to eat my cookies. So I take 16 cookies out every single day. It's like, how many days is that 864 cookies going to last? So if I take out 16 on one day, then I'm just going to subtract 16 and see how many I have left. But that's going to take an awful lot of time if I keep doing minus 16, minus 16, minus 16, minus 16. So I can take it out with multiples of 16 at a time. So for example, on this multiple tower, 160 is the biggest one that I see, right? So I know that if I took out 16 cookies 10 times, right, this is the 10th multiple, that would be 160. So if I took out 160 cookies, let's say in this example, that would be the 10th multiple of 16. That's like 10 days, right? So there would be 704 cookies left. So there's still a whole bunch of cookies in that cookie jar. Remember, I want to find out how many days until all those cookies are gone. So I know I can take out another 160 because, right, 704 is more than 160. So I can take out another 160. That would be another 10 multiples of 16. And I'd have 544 left. I can repeat doing this, take out another 10th multiple. You get this. Oh, that's still bigger. I can take out another 10th multiple, and I'm going to get 224. Looks like I can take out another 10th multiple, and I'm going to have 64. Now, can I still take another 10th multiple of 16 out of here? I can't take 60 cookie jars out of the I can't take 160 cookies out of the cookie jar when there's only 64 left, right? So I can look back here and say, well, I know it's going to be less than this. How many cookies could I take out? I have 64 left. Oh, look at that. I have 64 right here. So I could take 64 more out, which is the which multiple of 16. 64 is which multiple of 16? It is the, look, first, second, third, fourth multiple right here. So I can take out another 64. That's the fourth multiple. So now, really what you're saying is, how many times was I able to take out 16 out of this 864, right? How many groups of 16 were there in 864? There were 10, 20. I just count up my multiples here. And so this is what we do. We do a one line here. We just jot down how many multiples each of these numbers are. So I have 10, 20, 30, 40, 50, 54. That means I was able to take out 16 groups of 16 54 times out of 64. So, whoops, let me do, well, it's fine. So, the quotient here is going to be 54 for 864 divided by 16. Now, that worked great. Nothing wrong with that. I got my answer 54. We're going to do it another way, see if we get the same answer. And if we do, then we know that both ways worked, right? So, but let's see if we can solve this just a little bit faster. And yesterday, we talked a little bit about how if I know I can build my multiple towers up to infinity by just what knowledge I have, I can build on that. So for example, if I know that so here's my multiple tower. If I know that the 10th multiple of 16 is 160, then I know the 20th multiple would be twice as much, right? 20 is twice as much as 10. So twice as much as, I'm going to just write this, twice as much as 160 would be 320, right? That's twice as much. So this would be the 20th multiple by doubling my 10th multiple, right? But I want you to also think about this and notice this, because this is something that in last night's lesson anyway wasn't mentioned, is that if you look at the 20th multiple, yes, it's twice as much as the 10th multiple, but look at the second multiple. So the second multiple here is 32, and the 20th multiple is 320. What relationship do you see between the second multiple and the 20th multiple? It's 10 times as much, right? Just like we know that 20 is 10 times as much as 2. So the 20th multiple is 10 times as much as the second multiple, okay? So if we know that, then we can say, well, that means that the 10th, if this is the 10th multiple, if 160 is the 10th multiple, sorry about my messy handwriting, then if I multiply that by 10, I would get the 100th multiple, right? And the 100th multiple would be 1600, okay? And so I'm just going to show you a couple different ways that your brain can be thinking about these numbers and just how they're related. Remember that we've talked about, like, really, really important thing is going to help you in math is just being really familiar with math and understanding the relationship between them. So I can look at that and notice, well, 1600, well, that's about, that's about twice as much as that, right? That's twice as much as 800, which is a lot closer to this 864 than if I kept doing 160 every time. I can also look at this fifth multiple, right? So these are just a couple different ways. I don't need to be thinking about it all these different ways, but another way I can think of it is a fifth multiple is 80, so 10 times more than that would be 800, which again is really close to this 864. And so 10 times more than 80 is 800. 10 times more than the fifth multiple would be the 50th multiple, right? So the 50th multiple would give me 800, which is less than this 864, but is really pretty close, right? So now all I have left is 64, and then look at that. I'm looking at my multiple tower. I see that 64 is right here, and is my first, second, third, fourth multiple. So fourth multiple, and again, I just add the multiples together as I'm going, and that's 54. So it's the same quotient as when I was doing it the other way, with 10th multiple, 10th multiple, 10th multiple, 10th multiple. There isn't one right way to do this. There isn't one right pathway to get to the answer. As long as we're using this strategy, we'll get to the right place. So last one. This one is one that I would like you to solve. So go ahead and solve 336 divided by 12. Again, no calculators. And go ahead and solve. Go. Okay, so I'm going to show you one way that you could have solved it. It's by no means means that this was the only path to get to the right answer, but this is one that you could have chosen. So I had my multiple tower over here, right? And I said, well, the 10th multiple is 120. I could have done 120, 120, but I know that double that is 240, which is still less than that, so that's what I chose to do. 240, which would give me the, and I didn't write this down over here, but hold on one second. It's going to give me the 20th multiple, right? Because the 10th multiple is 20, so twice as much as that is the 20th multiple of 240. And then I know that, look, if I look over here, I'm looking at my number tower. I know that 96 is what's left. 96 is my 8th multiple. So that's my 8th multiple there. And now I have nothing left. I know I'm done. And those together, right? Those are all my multiples. Those amount of time that I was able to take out 12 gives me a total of 28. So, all right, that's what we're going to be working on tomorrow, and see you then.